So we're going to be asked to construct a sinusoid with an amplitude of 4, a period of 3 pi, and that it passes through the point 3, 1. So this is the same problem as what we had on 7 and 8. Just we've reduced the amount of information you've been given from, like, you're given as much information as we can possibly give you when we give you the entire graph to like a bare minimum of information. So let's look at what we have here. The amplitude is 4. Tells me that the absolute value of A is 4. So A is positive 4 or negative 4. Everybody agree with that? The period is 3 pi. That tells me that 3 pi is going to equal 2 pi times the absolute value of C. So the absolute value of C is equal to 3 over 2. Or that C is equal to 3 over 2, or negative 3 over 2. God bless you. You're welcome. Everybody so far so good with this? These two conclusions should have been pretty obvious to draw. Nothing tricky happened there. So now we're told that we also need the graph to pass through this point, 3, 1. So what is this point 3, 1 in some way going to tell us? It has to be able to tell us something about the h and the k. We don't know what yet, but there's no other way we're going to get h from the amplitude or k from the amplitude or h from the period or k from the period. Those are unrelated to those two attributes. So this passing through the point 3, 1 has got to tell us something about h and k. Everybody okay with that? Now there's an easy way to do this problem and a hard way to do this problem. It all comes down to the choice of which trig function you want to use to write your equation with. In the case where we're just told that all we need is that this point passes, or the function passes through this point, it doesn't tell us that this point is a minimum or a maximum or like is on the midline or anything else specific about it. We have our choice. That I can write a function where this point is at a maximum or on the midline or at a minimum. It's really kind of up to me. The easiest choice of where this point is on your function is if it's a midline point. Sure. And the reason that that's what I want to do is because then I'm going to use sine as my function. So on sine, one of my midline points is 0, 0. And that should map to 3, 1. So I know that c times 0 plus h and a times 0 plus k have to give me 3, 1. Well, it just tells me that hk is 3, 1. Which is the easiest possible situation, right? It's just, if it just all we have to do is pass through that point, I'm going to use that as I'm going to use the sine function, and immediately that point is my h and my k. So that's pretty righteous. Now, if that's the case, does it matter whether we pick the a's and c's to be positive or negative? Do we have enough information to determine whether they should be positive or negative in this problem? We don't, so you're free to pick either. So I'm going to just pick them to be positive. because we don't have enough information to say otherwise. And if you wanted to, you could distribute the 2/3 through, but I don't really need to do that. JJ. Yeah. Yes. Let's look at another example where we can make that determination. Ten. No, everyone's just really quiet all of a sudden. So this next example says construct a sinusoid that has a minimum value at 510 and a next maximum at 15,32. Sydney, this is a situation where we're going to be able to tell whether the A's and C's should be positive or negative. Because we're told something about what kind of points we have. So I'm going to start by just kind of drawing a picture here to look at what's going on. So we have like 510, say, is here, and then like 1532 is here. We're told that 510 is a minimum and 1532 is a maximum. So we have like that part of the graph. Everybody okay with that? Okay. So I can calculate K, because to calculate K I need the Y max and the Y min, which I have. 21. I can calculate the absolute value of A because, again, I need just the Y max and Y min to do that. Uh, 11. Okay with that. To find C, I need to figure out the period. So how much of the graph is that? How much of the graph have we drawn here? Looks like half of the graph, right? You guys agree with that? So I know 1/2 the period is equal to 15 minus 5, or 10. So if I do the period is equal to 2 pi c, I have 2 times 10, or 20, is equal to 2 pi c. So the absolute value of c is equal to 10 over pi. Okay. Is everybody okay with this so far? So we still have two things to do. We need to figure out whether those A's and C's are negative or positive, and we need to figure out H, I guess, and then we need to pick a function that we're going to use, whether sine or cosine. In this case, I know what kind of function I should be picking because of the information that's been given to me. Which one should I pick, sine or cosine? Cosine. Why would I want to pick cosine here? Because I know about the maxes and mins. If I know about maxes and mins, I want cosine. If I know about midline, or if I'm just given a generic point, I'd want to use sine. Okay with that idea? All right. So in my parent function for cosine, I have 0, 0 as a maximum. I have two choices here. I can map to my transformed function either to the maximum, which is at 15, 32, or I can map it to the minimum of my transformed function, which was at 5, 10. If I choose to do the minimum, what other thing am I going to have to account for here? My a needs to be negative. If I'm going max to max, the a has to be positive. Hopefully that makes sense, right? If I'm going max to max, there's no reflection. If I'm going max to min, a reflection had to happen there, right? Is everybody okay with that plan? All right. So I would have then c times 0 plus h, and then oops. That's a 1. Sorry, guys. You guys should have been caught that one, though. Right? The maximum of cosine is the point 0, 0. Yeah, right. Yeah, I wish you would have. That would have saved us all a lot of erasing. All right. And then I have a times 1 plus k should equal 15, 32. Now, do I care about what's going on with the k? Not a lick. All I really care about is the x part, which tells me h is 15. If I do the same thing over here, hopefully you guys won't find it hard to believe that h is 5. It does sound like a hospital in here. You guys don't sound so good. You need to lay off the vape. It's a good thing that we have this assembly on Monday about vaping. So, or you're sick of vaping. All right. So if I put this all together, then I have 11 cosine of, what did we say the c was again? Oh, I'm going to just write it as the reciprocal. X minus h plus k, or if I chose to go max to min, I'd have negative 11 cosine pi over 10 x minus h plus k. Don't use sine on a problem like this. It makes life much more difficult. Or at least, like, unnecessarily more difficult. You know what I mean? Most of our lives are hard enough. We don't need to make our math homework any harder. And it's a pretty easy rule to remember. Just, if you know about maxes and mins, use cosine. If you know about midline or just nothing in general about the location of the point, use sine. In which case, it basically boils down to the x-coordinate is the h. Should be 5, because in the second equation, the h is 5. Because we're mapping to the point 5, 10, rather than 15, 32. So yeah, that is all correct. But good question, Miguel. Yep, those are all fine things to ask about. Certainly not unreasonable questions. Do we feel okay about this kind of graphic or this kind of writing equation problem? We will do some more separate practice from this, separate from the homework, maybe on Monday or something, and give you guys a chance to work through some stuff in class. Okay? As I know that this is maybe one of the more challenging skills that we ask you to do. So I want to talk a bit about graphing now. So what I want to just kind of jog our memory on is this transformation map. This is going to be the key to doing the graphing for these sine and cosine functions. So this is something that you'd want to have memorized, I know. But it's really the same thing as just it's really the same thing as this, it's just written in a different form. So you notice the stuff that's applied directly to the x is here, and you notice the stuff applied directly to the f of x is applied directly to the y. These y and f of x are kind of the same thing. It's usually not that hard to remember if you think about it that way. If you can remember one of the two, then you can remember the other one. Anyways, so what we're going to do is we're going to identify some key points for sine and cosine. And we're going to use those key points then with our transformation to generate our new graphs. So the key points that we're going to use are going to be at the value of sine and cosine at 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So for sine, at 0 degrees, it's 0. At 90 degrees, it's 1. At 180 degrees, it's 0. At 270 degrees, it's negative 1. And at 360 degrees, it's 0. Notice, though, that when we're graphing, we're going to be using radians primarily. So I wrote, instead of 90, 180, 360, 270, etc., I wrote those in terms of radians. With cosine, at 0 degrees, it's 1. At pi over 2 or 90 degrees, it's 0. At 180 degrees, it's negative 1. At 270 degrees, it's 0. And at 360 degrees, it's 1. Do you need to memorize these? Not really, because they're on the unit circle, right? So you don't really need to memorize these. You'll use them enough that you'll probably end up memorizing them on accident. But they are literally just values from the unit circle, right? And they're just the quadrantal values. They're just the values at the quadrants. So you could memorize them, and that's fine to memorize them, but we're just talking about reading values from the unit circle. So if I'm going to give you the unit circle, which I would, you can always, if you don't remember the values, you could just pull them from the unit circle. You know what I mean? So let's say we wanted to graph y equals 2 sine of negative x plus pi. So the first thing I'm going to do is rewrite this so that it's obvious to me what my values for A, C, H, and K are. Is everybody okay there? I'm now going to use my transformation map. So when I fill in my values for C, H, A, and K, I have this as my map, and I'm just now going to apply this to the key points for, in this problem, sine, because what was the problem? It was a sine problem. So those are my 5 key points. So when I plug in 0, 0, I get pi 0. Mark. Okay. When I plug in pi over 2, I get negative pi over 2 plus pi, which is just pi over 2 again. And then 2. When I plug in pi, I get 0. And then when I plug 0 in, I get 0. When I plug in negative 3 pi over, or when I plug in 3 pi over 2, I get negative 3 pi over 2. And when I add pi, I get negative pi over 2. And then negative 2. And when I plug in 2 pi, I get negative pi, and then 0 again. So now I have my new transformed points. So I can draw this in. So I'm just going to go up by quarter pies. So that's a half a pi and 1 pi. It's negative a half pi and positive a pi. And then 1, 2, 1, 2. So I have pi 0, pi over 2, 2, 0, 0, negative pi over 2, negative 2, and negative pi over 2, 0. So if I draw my graph, look like this. And if I wanted to graph this over, say, from negative 2 pi to positive 2 pi and not just what I've done, what would I do? I'd just extend my graph in both directions. So after this point should be the minimum, and then back to 0. After this point should be a maximum, and then back to 0. So I'm not going to, beyond those 5 key points, I'm not going to generate any new points by hand. I'm just going to kind of follow the pattern. Because once I have one period worth of data, I can just keep iterating that data over and over and over again to fill as much space as I need. Does that make sense what I did at the end there? Just tacking on some more points to fill up the space. So depending on what the instructions are, you may have to just iterate a few more points, or you might have like a whole bunch of them to iterate. Like, just kind of depends. Does that feel okay there? Usually this goes pretty well. The biggest issue is like dealing with the fractions with the radians in there often for students. Just as a heads up, though, you can use your calculator to handle all of that nonsense. If you just drop the pi's off, like if I had 7/3 pi over 3 plus, 8 pi over 5, I'll just do 7/3 plus 8/5. Just drop the pi's off and then press math and fraction. And just say, oh, when I add those together, it's 59 pi over 15, and just tack the pi back on there. So you can get away with, if you have to do operations on the radians and you don't feel good with the fractions, like just drop the pi's off, do the calculation with the fraction on your calculator to get the result, and just tack the pi back on at the end. That's fine. Miguel? So one of the major advantages to radians is that it's computationally easier for a machine to operate in radians than it is in degrees, because the numbers are smaller. It requires much less storage on the machine to do like calculation with. So that's one of the big advantages of why we use radians in practice, is that when it comes to digitizing this, the machine handles the smaller number a little bit better than the bigger numbers. So maybe a better answer than you were expecting with why we're using radians versus degrees, even though usually intuitively we're more comfortable or familiar with degrees than we are with a radian. Yeah, which is, again, not surprising. You're just seeing them for the first time, most of us, in this course, so that's okay if you're still feel like you're playing catch-up and radians feels awfully foreign. That's fine. Like, that's not unexpected. You're in a fine spot. This is as much as I wanted to do today.